Greetings everyone, this is Non-Expert here, back again with another video. Today we are going to be solving problem number 17 of our 30-day LeetCode challenge, and the problem which has been given to us today is number of islands. We've solved this problem before, so this should be comparatively quick, but let's just go through the problem description. So if you want to try solving this problem, you can find the link in the description below. And let's just dive right in. So the problem description is that given a 2D grid map of ones and zeros, one representing a land and zero representing water, you need to count the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume that all four edges of the grid are all surrounded by water. So you've been given an example over here, and basically what you have is a matrix or a list of lists. And essentially what you want to do is you want to count the number of islands. And an island could basically be represented as anything which is connecting your ones together. So one represents land, and you can see over here there's a L sort of a thing forming over here. So that basically means that there's only one island because there's over here also. So you count this and so on and so forth, and that sort of makes the total number of islands as one. So basically, if you have a one which does not have any connecting other ones, well, that will be a separate island. So you can have a look at this example, and you can see that one over here does not have any connecting islands. And the way we sort of defining connections are by saying that they need to be connected vertically or horizontally. Not you can't go like diagonally over here. So over here, you can see that the number of total islands is three, and that's basically the entire basis of your formula. So if you don't know about the algorithm which we are going to be using today, we are going to be using a DFS approach, and most likely the time complexity of this DFS approach is going to be n into m, where n is going to be the number of rows and m is going to be the number of columns. And if you don't know what a DFS is, I would sort of urge you to check out my earlier videos, but I'll try to sort of go through it over here as well. And this is a must-know problem when you're going for interviews as well. So let's just go through a problem. Let's just try to solve this problem. So we always start with a base condition, which is just going to be, hey, if no grid has been given to us, then you return a zero. Pretty straightforward. Now what I'm going to try to do is, whenever you try to do DFS or anything rather, you should have a lot of functions already in place. And we'll sort of talk about the usefulness of functions. But also you want to make your code as readable as possible. So what I'm going to do is I'm going to sort of create a list of directions, which is going to have which direction can we actually go into. So if you don't know what I'm doing over here, it's basically I'm constructing a list of lists. Pretty straightforward. And what it essentially does for me is if you sort of add a direction to your ith and jth value, this particular value should basically go up when you add it, because you're basically subtracting the ith value, and this is going to be the jth value. So when you subtract the ith value, that becomes whatever's on top. When you add an ith value with 1, that goes down. When you sort of do the same thing with j, when you're holding I constant, you basically go on your left, and when you increment j, then that goes on the right. So basically, in a sense, you're saying that this is top, this is bottom, this is left, and this is right, to whatever element that you're presently on. So this sort of a way, sort of helps us identify like which direction should we actually go under, and that's really useful for us. The other thing that we can do is we can also declare a lot of utility functions, which obviously in DFS you'll sort of use recursion. So mostly, you'll sort of have a function which will be declared. But apart from that function, you should also have another function called as isSafe, which can sort of check all your boundary conditions as well. So we'll do isSafe, we'll not pass in any parameters, we're just sort of, just making a small thing. And we're going to have a utility function, which is basically going to run as a DFS. And eventually what we want to do is we want to maintain a count, and when we iterate through all the values, and before I sort of do that, let me just make a few other values. So let's just say n is the length of grid and m is the length of grid of 0. So basically the number of rows and the number of columns. So when you sort of go through all this approach, what you're going to do is you're going to iterate through all the values or sort of all the elements inside your matrix, and You can see the iteration. It's a pretty simple for loop with a for loop, pretty basic, so that you can iterate through each and every single element inside your matrix. And what you essentially want to do is you want to check whether you want to do processing on this thing if the value inside your grid is actually equal to a 1. And 1 over here, I believe, is like determined as a string, so that's why I've sort of given it as a string. And when that happens, that's when you sort of call your utility function. And eventually what we want to do is we want to return a count. And a count would sort of be updated whenever you have something. So what we're going to do is when we sort of call the utility function, it's going to pass through all the other adjacent or sort of all the other neighboring land values. And when it does that for us, we can maintain that whatever it has visited by using a visited dictionary as well. So all in all, what you're going to do is you're going to contain all the values which have already been visited inside a dictionary, and you can pass in, as you know, you can pass in a tuple because tuple becomes hashable, is hashable by design. So you can pass that in, and then you can sort of construct that thing out. So we're going to add a few things inside our grid I and j, and what we're going to say is if the grid has 1, and also if I comma j is not unvisited, then only do we move forward. So this way we are not just counting the number of ones, but we're counting the number of ones which are now unique, which we've not traversed through. And inside our utility function, we're going to pass in a few things. So we're going to pass in, we don't really need to pass in the visited because visited is over here and that's like still inside the scope of that utility function. So basically we can just pass in I and j. And when we do that, we need to sort of now construct our isSave function. And our isSave function is going to be pretty simple. It's just going to be like, hey, if your ith or your jth element are invalid, well, in that case, or have actually been visited before, in that case, we return a false. Otherwise, we return a true. So we say, hey, if I is less than 0, which is obviously, it'll go out of bounds, well, that's incorrect. Or I is greater than or equal to n, or the same thing with the j, whether it's sort of inside the boundary of our conditions, and it's greater than equal to m. In all these cases, we're going to return false. And I'm just going to add up on all these statements. I'm just going to add a few more conditions. Now I'm going to say, hey, if I and j have been visited, then we need to return a false again, and we eventually return a true. So this just checks all the boundary conditions for us and checks whether the ith and jth values either have been visited or they have been, they are inside our matrix at least. So the way we can use this function that we sort of defined, the if save is save function, is by just calling an if condition, and we can say, hey, if this thing is sort of returning a false, then we need to return the thing. We just need to break out of this recursion. Or at least not break out of this recursion, but at least not iterate anymore. We also need one more condition which can just say, hey, if my I and j are not equal to 1, then I don't really need to do anything. I can just break out as well. This is the expected return of the utility, but you can sort of pass in a value which you can use, but over here it's not really required. Now sort of comes in the part of using the DFS approach. So if you're not really familiar with DFS, whenever you look at any patterns which are using, any functional patterns which are using DFS, you'll see recursion, and inside the recursion there will be a for loop sort of also identified over there. So when that happens, it sort of calls all the values as sort of moving forward with it. So what we're going to do is for us, we're going to call all the directions. So we're just going to call for direction in directions. And do remember that this is going to return another list which is going to have I and j. So we can basically unpack this and just say d comma j. And what we want to do is we want to like update our utility function. So to the utility function, we're just going to pass in the new the new I and uj when you sort of increment it with di and dj. So that's pretty simple. You can just say d underscore I and j plus d underscore j. Basically, you're just adding whatever ith and jth element that you had as a parameter, and you're constructing a new, basically calling the same function again, and it only breaks out if and only if grid is either not equal to 1. Actually, let's make this a string because that's going to hurt us otherwise, or if it's not inside the boundary conditions. And that's basically it. So let's just go ahead and try to run this. I usually make mistakes when I run this, so let's see whether this thing is running. And great, you can see that I have made a mistake, so let's just see what the mistake is. And it seems like it's going under, it's calling a maximum recursion depth error, which means that we are not able to break out of this loop properly. Um, so let's just see like what exactly are we missing out over here to identify how. Yeah, so I do see the error which I've made. And again, like I usually always make this error. It's just like inside visited. And okay, so let's just debug this for a second. So this is a recursion error, and it sort of comes in Python a lot because if you don't know why people use recursion over why people use inside your dynamic programming, you would have noticed that why do people use um, another memoization technique, and why don't they just use just the recursion thing? Apart from just the added benefits, you will see that in essence, when you call recursion sort of goes inside memory, inside your call stack. And that call stack in memory is sort of, it's not going to be allocated that much space. But when you sort of create your own stack, that stack which you've created sort of goes inside your other heap memory. And if you're not familiar with that, it's just like it's the bigger memory portion. So basically, that's why people sort of control for that. Keeping that aside, a recursion error sort of shows you that you're not breaking out of the loop properly. And the only reason why this breakage will not happen is if you have a cycle sort of going forward. So basically you go here and then you go on the left, or sorry, you go on the right, but then you go on the left and then you go left, right over and over again. And the way to control for that is just using the visited values. So what we need to do is we've already had that is safe condition, and all we need to do over here is that if all these markations have happened, you can basically set your I and j inside your visited and just give it some random value, and that's basically it. So this should stop our errors and this should run fine now. You can see like it's the correct solution, and let's go ahead and submit this. Hopefully this should get submitted, and awesome, you can see it's been accepted. And that's basically the entire approach of why you would want to use a DFS approach to solve this problem. Now, in essence, like again, like to be very honest with you, people don't really use DFS as much if they don't know how many conditions they have to place in. Over here, we've sort of already know that we sort of already identified the number of conditions which we would have through the is safe condition, so that was sort of easy for us. But when your code sort of gets a lot more complicated, or if you want to know what's the path which was taken and all these things, it becomes a lot more trickier to do that in DFS, and that's when people sort of switch over to the BFS approach because you have control over a lot of other things as well. But that was it for today's solution. If you didn't understand something, do leave it in the comment section below. And if you did like this video, do give a like and do subscribe to our channel. We are discussion over here, and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you.